Hi everyone, welcome to Homeschooling SAT Prep channel. Today we are going to start part 2 of triangles. In part 1, we have already covered basics of triangles, and after that we have covered 10 questions on angle sum of triangle, relationship between angle and side, shadow and proportionality, and special right angle triangle. In this part 2, we are going to cover basic conditions of similar triangle. Then we'll take 10 questions on proportional side length and properties of lines and angles. So if you haven't watched part 1 yet, I'll request you to go watch part 1 first, then come to the part 2. In part 3, we are going to cover congruent triangles along with some previous year hard SAT math questions related to triangles. Now let's start the video with the basics of similar triangles. So what are similar triangles? So two triangles are called similar when they have same shape, but they can have different sizes and they need to follow either of these two conditions. So the first condition is they need to have same set of corresponding angles and the side needs to be proportional or of same ratio. Let's take an example here. In example number 1, we can see we have two triangles, triangle XYZ, and we have another triangle PQR. So as we can see, both of them have similar or same shape. So they have same shape, but their sizes are different and they need to follow one of these two conditions to be similar. So as you can see, angle Z is equal to angle P. Both of them are 40 degree. Then angle Y is equal to angle Q. Both of them are 80 degree. And angle X is equal to angle R. Both of them are 60 degree. So it is following the first condition that they are having same set of corresponding angles. So angle Z and is equal to angle P, angle Y is equal to angle Q, and angle X is equal to angle R. Now the second condition for a similar triangle is called they need to have proportional corresponding sides. So let's take the first angle here, so 40, 40. So opposite side of these two, of this angle 40 in both the triangles is 10 and 5. So Y X divided by QR. So that is equal to 10 divided by 5. So that is 2 by 1. Similarly, let's take the opposite side of 80 degree. So opposite side is XZ, XZ, and here PR divided by PR. So that is 6 by 3. So they are having same ratios. Now let's take the third one here. So opposite to 60. So opposite to 60 in the larger triangle is XZ, sorry, YZ, and in the smaller triangle it's PQ. So the value of YZ is 8 and PQ is 4. So 2 by 1. So as we can see, the corresponding sides are in same ratio, that is 2:1. So whenever a triangle follow either of these two conditions, they are having same angles in both the triangles or their sides are in same proportions. Then those two triangles are called as similar triangle. Now let's take a few more examples here. Let's take this example number 2. As you can see, PQR, and this is a triangle XYZ. So can you tell me that these two triangles are similar or not? I'll give you 5 seconds. Okay, now these two triangles are similar. In previous part, we have read about some angle of a triangle, that the sum of all the angles in a triangle is 180 degree. So if this one is 60, angle Q is 70, then this angle would be 180 minus 60 minus 70. That is going to be 50 degree. Similarly, in this triangle, this angle is 60, this is 50. So this is going to be 180 minus 60 minus 50. That would be 180 minus 110. That would be 70 degree. So now as you can see, angle P is equal to angle X, angle Q is equal to angle Y, and angle R is equal to angle Z. So they have same sets of corresponding angles. So that means these two triangles are similar triangles. Now, what about this example number 3? I'll give you 5 seconds to think about this question. So tell me, this triangle is a similar triangle or not? Most of you have thought that this is not a similar triangle, but it's incorrect. This is a similar triangle. Now, in first triangle, angle A is 45, angle B is 60, and here angle F is 60 and angle E is 45. What if we rotate this triangle by 90° in anti-clockwise direction, and let's redraw this triangle again. If we redraw this triangle again, it will be like this. If we rotate it in 90 degrees, so this is going to be F, this is going to be G, and this is going to be E, and E is 45°, and F is 60°. Now, we know that the sum of all the angles in a triangle is 180 degrees. So what is going to be this angle? This angle is going to 180 minus 60 minus 45, 105. So 180 minus 105 would be 75 degrees. Similarly, this angle would be also 75 degrees. So these two triangles are similar triangles. One more thing that you need to remember, that if two angles are given, automatically the third angle would be equal. So if two angles are already equal in a triangle, then third angle would be automatically equal because of angle sum of a triangle property. Now let's come to the fourth example here. We have two triangles here, DCE and RSQ. So tell me, this triangle is a similar triangle or not? Okay, now let's try this question. As we can see, on this side it's 20. So what we're going to do here is, as we can see, this side looks similar to this side, SQ. Then this side, SR, looks similar to, because the slope of this side is almost similar to this side. And this side is similar to this side. Now let's see these sides are proportional or not. So CD from this triangle and SQ from that triangle. So SQ. So CD is 20 and SQ is 8. So if we further solve it, that is going to be 5. 4 times 2, 4 times 5. So 5 divided by 2. Now let's take the other set of other sides here. That is CE and SR. SR. So CE is 10, SR is 4. So 2 times 5, 2 times 2 is 4. So 5 divided by 2. Now let's check for the third side. That is DE by RQ. So DE is 15, RQ is 6. So 3 times 2 and 3 times 5. So as we can see, the corresponding sides are proportional. That is, they are in proportion of 5 divided by 2. Hence, these two triangles are similar triangles. So from this, we can derive that these three ratios are equal to each other, because all three of them is equal to 5 upon 2. So we can write CD upon SQ is equal to CE upon SR is equal to DE upon RQ. Because all of them are equal to each other, so we can equate these three side ratios. So from this equation, we can also make three more equations. We can equate these two ratios, then these two ratios, and then these two ratios. So from this, we can derive that CD upon SQ is equal to CE upon SR, or CE upon SR is equal to DE upon RQ, or CD upon SQ is equal to DE upon RQ. SQ equal to DE upon RQ. So if triangles are similar, we can equate this side ratios of two similar triangles like this. Now, in sometime in question, instead of writing two triangles are similar, sometimes they will write triangle ABC is similar to triangle PQR. So this sign means that these two triangles are similar. Now let's move on to the questions. The first type of question that you're gonna get in similar triangles is to check the conditions for similar triangle. So first of all, how are you going to find that a particular triangle question is a similar triangle question? So either in the question, similar triangle will be written, or in the figure of the question, you can see two triangles of same shape, but it might have different size. Or you can see two similar triangles, but one triangle is flipped. Or you can see two similar triangles in which one triangle is overlapping on the other similar triangle. So if you find these figures, that means most probably that question is from a similar triangle question. The first type of question that we're going to get in similar triangles is to check the conditions for similar triangles. So what are the conditions for similar triangle? the condition for similar triangles are they need to have same set of angles and this need to have same side ratios. So in the question, in triangles LMN and RST, angle L and R are 60 degree, angle L and angle R is 60 degree, LN is 10, RT is 30. Which additional piece of information is sufficient to prove that these two triangles are similar? So either they need to have same sets of angle or they need to have same side ratios. Let's check each option one by one. So first option, Mn is equal to 7 and St is equal to 7. So Mn is 7 and St is 7. As we can see here, this side ratio is 3 times of this side, or we can also say the reverse of that, that ln is 1/3 of this side, but here it is not 1/3. So we can also write it like this: RT upon ln is 30 upon 10, that is equal to 3 upon 1, and ST from the larger triangle upon Mn from the smaller triangle is equal to 7 upon 7. So that is 1 upon 1. So it is not following the second condition that the ratios need to be same. Here RT upon ln is 3 upon 1 and ST upon Mn is 1 upon 1. So the first condition is incorrect. Now let's try the second condition here, where Mn is 7. So Mn is 7 and ST is 21. So we can, as you already know, that ln is 1/3 of RT. Similarly, Mn is 1/3 of ST. But we don't know the exact length of this. But for the condition of similar triangle, all the side ratios need to be same, but we do not know the length of these two sides. So we cannot find the ratios. So option B is also incorrect. Now let's try option C here. The measure of angle M and S is 70 and 60. So sum of all the angles in a triangle is 180 degree. So if these two angles are 60 plus 60, 120. So this angle would be 180 minus 120, that is 60 degree. And in this triangle, sum of these two angles, 70 plus 60, that is 130. 130, and so 180 minus 130 would be 50 degree. So as we can see, all the angles are not equal here, because for similar triangles we need to have same set of angles, but here we are having different sets of angle. So option C is also incorrect. Now let's check option D here. Angle M and S is, angle M is 70 degree and angle S is 50 degree. So the sum of all the angles in a triangle is 180 degrees. So 60 plus 50, 110. So 180 minus 110, that would be 70. And here the two angles are 70 plus 60, so 130. So 180 minus 130, that would be 50 degrees. So as you can see, these two angles are similar, these two angles are same, and these two angles are same. So as per the condition of similar triangles, they need to have same sets of angle. So they're having same set of angle. That means triangle RST is similar to triangle LMN. Now the next type of question is called as proportional side length, and we are going to solve these type of question using long shot method. In the question, as you can see, we have two triangles, triangle ABC and triangle PQR, and we have to find what is the length of QR here. So for that, we first need to see that these triangles are similar or not. So there are two conditions for similar triangle. Either it needs to have same set of angle or same side ratios. But here, as you can see, this side length, this side length, and this side length is missing. So we cannot find side ratio. Let's check for the other condition, that is that these two triangles are having same set of angles or not. So angle B is 90 degree and angle Q is also 90 degree. Similarly, angle A is 30 degree and angle P is 30 degree. So when two angles in a triangle is equal, then automatically the third angles would be also equal, because sum of all the angles in a triangle is 180 degree, and the sum of these two angles is 90 plus 30, that is 120. So 180 minus 120 is 60 degree. Similarly, this angle would be also 60 degree. So if in triangles, if two angles are same, automatically the third angle will be same. So now, as we can see, they have same sets of angle. Angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. So they have same sets of triangle. So from this, we can say that triangle ABC is similar to triangle PQR. When the triangles are similar, it will follow both the conditions. So it is already having same set of angles, but now it's a similar triangle. So we can say that they will have same side ratios. So for that, what we're going to do here is we're going to take two corresponding sides. So we are taking this one and this one as corresponding side, and this one and this one, because we have to find the value of QR here. In the first slide at the end, I have taught you that all the side ratios were equal to 5 upon 2. So from that, we can equate the various side ratios. So we're going to do the same thing. So what we're going to do is we're going to take the longer side in the numerator and the smaller side in the denominator, corresponding smaller side length in the denominator. So AB upon PQ is equal to, similarly, we'll take the other side from the larger triangle, that is BC, and we'll take the corresponding side from the smaller triangle, that is QR. And as we know, in similar triangles, side ratios are same. So we can equate these side ratios. So AB value is 12. See why this is called as a short, long, short, or short, long method, because we are taking the longer side on the numerator and the shorter side on the denominator. Similarly, here we are taking the longer and the shorter in the denominator. We can also do the reverse of it. We'll still get the same answer. So AB divided by PQ, that is 4, is equal to BC. BC is 9. And we have to find what is QR. So we'll cross multiply them. So 4 times 9. So 4 times 9 divided by 12. So QR is 3. So option A is your correct answer. See, you need to remember one thing. When two triangles are given, first you need to see that those triangles are similar or not. So they need to either satisfy one of these two conditions. So after satisfying one of the condition, then automatically the other condition will be satisfied. There's one more shortcut method to solve these types of problem. As you can see, these two triangles are similar. So when triangles are similar, they will have same side ratios. So we will compare the corresponding sides here. So as you can see, PQ, that which is 4, is 1/3 of AB, because 1/3 of 12 is 4. Similarly, QR would be also 1/3 of BC, that is 9. So 1/3 of 9 is 3. So QR will be 3. So this is the shortcut method. Now let's move on to the next question. In the question, it is already given that triangle QPR is similar to triangle STR. So these two triangles are similar to each other. The length represented by ST, QP, PR, and QR in the figure are 14, 15, 20, 25 respectively. We have to find what is the side length, what is the length, SR. So let's take this triangle, this smaller one, and let's redraw it. Let's flip the triangle and redraw it. So this is S, this is R, and this is T. This is 90 degree, this is 40. So we can redraw this triangle. We are just flipping this triangle. Now let's compare these two triangles, triangle QPR and triangle STR. And this angle is X degree. So we have to find what is the length of SR. So SR is what? So as you can see, in both the triangles, the larger and the smaller, these two sides are corresponding to each other, and similarly these two sides are corresponding to each other. So we're going to write the ratios. So we'll first write the larger length, so that is QP, and the corresponding side length in the smaller triangle, that is ST, divided by ST, is equal to QR divided by SR. So QP is 15, ST is 14, QR is 25, and we have to find what is SR. So we'll cross multiply them. So after cross multiplication, 14 times 25 divided by 15. So 3 times 5, 5 times 3, 5 times 5. So it's going to be 70 divided by 3. Now let's check the option here. As we can see, we don't have this answer in the option. So what we're going to do here is we're going to multiply numerator and denominator by 5. So 70 times 5, that is 350. And 3 times 5 is 15. So SR value is 350 divided by 15. So option A is your correct answer. Now, I want you to pause this video here and try this question by yourself. I'll start speaking after 5 seconds. I hope you have tried this question. In this question, two triangles are shown and the relationship between the side length of the two triangles are given. That is AB upon DE is equal to BC upon EF is equal to AC upon DF is equal to 3. So we can also write 3 as 3 upon 1. Still going to remain the same thing. And the measure of angle BAC is 20 degrees. So this angle is 20 degree. So what is the measure in degree of angle EDF? So we have to find this angle. So first we need to find that these two triangles are similar or not. So either it needs to have same set of angles or same side ratio. So as we can see here in the question, the side ratio, that is AB upon DE. So these two are corresponding side. They're having ratio 3:1. Similarly, BC upon EF. So BC upon EF, these two corresponding sides are also having the ratio of 3:1. Similarly, AC upon DF, they are also having the same ratio. So in these two triangles, they have same side ratio. So when they are having same side ratio, that means they are similar triangles. So from this we can say that as both triangles have same side ratio, hence triangle ABC is similar to triangle DEF. Now, once the triangle is similar, it will follow both the conditions. So they will have same set of angle. So if this angle A is 20 degree, then the corresponding angle will be also 20 degree. Similarly, this angle will be equal to this angle, and this angle is equal to this angle. So angle BAC is 20 degrees. So angle EDF is corresponding to angle BAC. So angle EDF is equal to angle BAC because both of them are corresponding angles, which is equal to 20 degrees. So option A is your correct answer. The next type of triangle question will be based on properties of lines and angles. In this question, segment AE and BD are parallel. So BD is parallel to AE, and angle BDC is 58 degrees, and angle ACE is 62 degree. What is the measure of angle CAE? So we have to find this angle. So let's first take this triangle, triangle BCD. As we know, sum of all the angles in a triangle is 180 degree. So sum of these two angles is 62 plus 58 is 120. So this angle would be 180 minus 120. So this angle is 60 degree. Now we have read in lines and angles that when two parallel lines are there and a transversal line is passing through it, then their corresponding angles are equal. These two are corresponding angles. Corresponding angles are equal. If you draw a transversal like this from here to here, then these two corresponding angles will be equal. And if we draw it further, it will make a diagram like this. So this angle will be equal to this angle. So angle CBD is 60 degree. So angle CAE would be also 60 degree because angle CBD and angle CAE are corresponding angles. Now in this question, MQ and NR intersect at P, and P is equal to QP. So this side NP is equal to QP, and MP is equal to PR. So MP is equal to PR. What is the measure in degree of angle QMR? QMR. So we have to find what is this angle here. So as we know that when two sides of a triangles are equal, then it is an isosceles triangle, and isosceles triangle, the opposite angle to the equal sides are also equal. So if this side and this side are equal, then their opposite angles will be also equal. So this angle and this angle will be also equal. And we have read in lines and angles, when a transversal line passes through a horizontal line, then the sum of these two angles would be 180 degree. So if we take MQ as a line, then sum of these two angles will be 180 degree. So if this angle is 60 degree, so this angle is going to be 180 minus 60, that is 120 degree. And as we know, these two angles are equal because the opposite sides are equal. So let's take both the angle as x. And as we know, sum of all the angles in a triangle is 180 degrees. So this angle plus this angle plus this angle, that is 120. The sum of all the angles in a triangle is 180 degree. So 2x would be, if we take 120 on the other side, so 180 minus 120 would be 60. So x value would be 60 divided by 2. That is 30 degree. So angle MRQ, MR is equal to 30 degrees. So option B is your correct answer. In question number 7, in the figure, LQ intersect MP at point R. So LQ is intersecting MP at point R. And LM, this line LM is parallel to PQ. And the length of MR, LR, RP are 6, 7, and 11 respectively. So we have to find what is LQ. So LQ would be LR plus RQ. So in lines and angles, we have read that when two lines are parallel, and if a transversal line passes through it, then the alternate angles are equal. Similarly, if we take another transversal line passing through it, then the alternate angles will be equal. And these two angles are vertically opposite angles. So what vertically opposite angles are also equal. So as we can see that in these two triangles, they have same set of angles. So we can say that these two triangles are similar. If we rotate this diagram, it's going to look somewhat like this. So we'll put the marking here. So L, M, R, P, and Q. So as we know, LM and PQ were parallel and they were intersecting at point R here. So MR is 6, LR is 7, and PR is 11. So as we can see, both the triangles LMR and PQR, both the triangles are having same set of angles, because this angle is equal to this angle, this angle is equal to this angle, this angle is equal to this angle. Hence, both the triangles have same set of angles, so we can say that triangle LMR is similar to triangle PQR. So as these two triangles are similar, so they will have same side ratios. They will have same side ratios. So now we need to find the corresponding side. So LR, so this side, what is going to be the corresponding side? So whenever you have these types of diagram, just look for the angle. So as you can see, opposite to LR, we have this second angle, and these angle M and angle P are equal. So whenever we have to find the corresponding sides in both the triangles, we are going to follow the angle. So this side is opposite to this angle, so the corresponding side on the other triangle would be opposite to the same angle. So this is going to be a corresponding side. Similarly, corresponding side for MR would be, so it is opposite to the first angle, so the corresponding side to the first angle in the other triangle is PR. So these two are corresponding sides. So we can write the ratios here. So the ratio would be LR upon RQ. So these two are corresponding, RQ and is equal to MR upon RP. So LR is 7, RQ, MR is 6 upon 11. So from this we can say that RQ is, by cross multiplication, RQ is 77 upon 6. We have to find what is LQ. So LQ is LR plus RQ. So LR is 7 and RQ is 77 upon 6. Into the 6, 42 times plus 77. So 42 plus 77 is 119 upon 6. So option D is your correct answer. Question number 8, the area of triangle ABC is at least 48 but not more than 60. If y is an integer, what is one of the possible value of x? So this diagram is given to us. What I have done here is I have separated both the triangles in this figure. So I've taken the larger triangle ABC here. In ABC, height is y, and our base is 5 plus 7, that is 12. In the smaller triangle ADE, we have taken it separately. So here we were having height as x and base was 5. So as you can see, these two angles are equal. Angle E and angle C are equal because both of them are 90 degree, and angle A is common here. So both ang the angle A would be same here. So as we have read, when two angles are same, automatically the third angle would be also same. So now from this we can say that angle ADE and triangle ABC are having same set of angles, and so we can say that triangle ADE is similar to triangle ABC. Now, because these two triangles are similar, so they will have same side ratios. Now, what you're going to do here is, in the question, the area of triangle ABC is from 48 to 60. So area of triangle ABC is equal to half times base times height. So it would be 12 times 2, 12, and height is y. So it's going to be 6y. And the question, it is given that the area of triangle is up to 48, from 48, and it goes up to 60. So we can compare 6y to both 48 and 60. So from this we will get y is equal to 8 to y is equal to 10 here. So if y value is greater than 8 but less than 10. So we have three integers here between 8 and 10, 8, 9, and 10. Now let's find the corresponding ratios. So this side is corresponding to this side in the bigger triangle, and this side is corresponding to this side in this bigger triangle. So we're going to write the ratios of the corresponding side. So we'll take the longest side first. So AC upon AE is equal to BC upon DE. So AC is 12, AE is 5, BC is Y, and DE as X. So as we know that the area was varying from 48 to 60, from that we find the value of Y. So Y value is from 8 to 10. So we have three integers from 8 to 10, 8, 9, 10. So what we're going to do, we're going to put three cases. In case 1, we will take Y value as 8 here. So when we'll put Y value as 8 in equation number 1, so it's going to be 12 upon 5, Y is 8 upon X. So from this, X would be 8 times 5 upon 12. So when we'll further factorize it, it's going to be 10 upon 3. So we have, in case 1, we have value as 10 upon 3. Now let's take case 2, where Y value is 9. So it's going to be, we'll take the ratio here, it's 12 upon 5, and Y value is 9 upon X. So from this, X is equal to 9 times 5 upon 12. So your answer would be 15 upon 4 in case 2. Now in case 3, when Y is equal to 10, so 12 upon 5, we'll put Y value in equation number 1. So 12 upon 5 is equal to Y value is 10 upon X. So X value would be 5 times 10 divided by 12. So that is going to be, if we solve it, it's going to be 25 upon 6. So we have three values of X here. The first value is 10 upon 3. The second value is 15 upon 4. And the third value is 25 upon 6. So when we put various values of Y as 8, 9, and 10, we got three answers. So all of the above answers are correct. In question number 9, in right triangle ABC, angle C is the right angle. So let's draw the triangle here. So we have a triangle ABC, and angle C is right angle. BC is 162. Point D is on side B. So point D is on side B, connected by a line with E on side AC, such that the line segment DE is parallel to line BC. And in the question, it is given that C is equal to twice of A. So we don't know what AE is. Let's take AE as X. So C is twice of A. So if we have taken AE as X, so it would be 2 times X, so 2 times X. And cumulatively, AC would be X plus 2X. That would be 3X. So AC value would be 3X. And we have to find what is the line segment DE. So as you can see, we have two triangles here, triangle ABC, and we have a smaller triangle AED. So first we need to check that these two triangles are similar or not. So triangle AED and triangle ABC. As we can see, these two are parallel lines, and ED and CB are parallel lines, and this is a transversal line. So on transversal line, corresponding angles are equal. So if this is angle C is 90 degree, then angle E is also 90 degree. So angle C is equal to angle E, and both of them are equal to 90 degree. And as you can see, angle A is common both the triangles. So angle A is equal to angle A in both the triangles. So as we have read before, that if two angles are equal, then automatically the third angle in both the triangles will be equal. So from this we can say that we have same set of angles here. These two triangles are similar. They have same side ratios. So in triangle ABC, we'll take the longer side AC here. So AC. In smaller triangle AED, we'll take the corresponding side, that is AE. So AC upon AE. And then in the larger triangle, we'll take this side BC. And in smaller triangle, the corresponding side is ED. So we have taken AC as 3x and AE as x, and BC value is 162 by ED. So ED is equal to 162 divided by 3. So 54. So option B is your correct answer. In question number 10, in triangle ABC, the measure of angle B is 90 degree. So let's draw it. This is triangle ABC. The measure of angle B is 90 degree, and BD is the altitude. So BD is the altitude, and altitude is perpendicular to AC. Whenever we are drawing a altitude, it is going to be perpendicular to the base. And the length of AB is 15, and length of AC is 23 greater than AB. So AB is 15, so AC is 23 greater than 15. So that is going to be 38. AC is 38. We have to find the value of BC upon BD. So first we have two triangles here, triangle ABC and triangle BDC. So first we need to find that these two triangles are similar or not. So as we can see, in the larger triangle ABC, we have one angle B as angle B is 90 degree, and similarly angle in smaller triangle BDC, angle D is also 90 degree. So angle B is equal to angle D, and in both the triangles, angle C is common. So angle C is equal to angle C. So when two angles are equal, then automatically the third angle would be also equal. So this angle would be equal to this angle. Hence, these two triangles, triangle ABC will be similar to triangle BDC. So when two triangles are similar, they will have same side ratios. So now we're going to take the sides here. So hence both the triangles are similar. So we'll take side AC, that is opposite to 90 degree in the larger triangle. So we're taking the longer side AC here, opposite to 90 degree. Similarly, we'll do the same in the smaller triangle BDC. So opposite to 90 degree is BC. So these two sides are corresponding to each other. Similarly, angle C is common here. So opposite to angle C would be, in the larger triangle, it would be AB, and in the smaller triangle, it is BD. So upon BD. Now we're going to put the value. AC is 38, BC, AB is 15, and on BD. So we have to find the ratio. So we'll cross multiply them. So BC upon BD is equal to 38 upon 15. So option D is your correct answer. Now these are some practice questions on the topic which I have taught you recently in this video. Do try these questions to test yourself and write the answer in the comment section below. So this is end of part 2. Don't forget to watch part 3 of triangles, where I'm going to cover congruent triangles and some previous year hard SAT math questions related to triangles. If you like the way I teach and want to buy a comprehensive course for SAT exam at a very affordable price, you can check out our homeschooling app and website. All the links are provided in the description. One more thing, don't forget to like, share, and subscribe to this channel so that you can get updates of upcoming free video that I'm going to upload on YouTube in future. Thank you very much, and may God bless you.